So, can you all hear me?
Yeah.
Yeah.
Okay, very good. My name is Keith Bennett. I'm originally from the United States. I left the country a few years ago. I do visit there every year, but I don't live in the US anymore. I live in Thailand and the Philippines. I move around to different places. And in 2018, I presented at RubyConf Philippines about command line applications in Ruby. And I began the presentation by singing a song about Ruby, but don't worry, I'm not going to do that tonight. Recently, with the improvements in AI coding assistance, I have been really inspired to do a lot of open source work, revisiting old projects, and because I'm so much more productive with it than I was by myself. And so the application that I showcased in that presentation talk several years ago was called Wi-Fi Wand, and it was an application that presented the Wi-Fi functionality of the Mac on the command line in a simple unified interface so that you could just call commands to list networks, connect, and do all kinds of things with networking, and didn't need to know about the underlying OS commands. Since then, I started using Ubuntu a lot, Ubuntu Linux, and I've always hoped that I could implement an Ubuntu version of Wi-Fi 1, but it was just too daunting. Well, since AI came along, I decided that now was the time to do it. So I started working with it, and one of the interesting things about this Wi-Fi thing is that when you want to test not only the unit tests, but you want to make sure that when you turn the Wi-Fi off, it really turns off. And when you connect to a network, it really connects. So you really need integration tests. Right? So I revisited the testing, and because I was working for two operating systems, I could only test the Mac when I was testing on a Mac, and I could only test Ubuntu when I was running Ubuntu. And the default was to not test either of them in integration tests, because who wants, the Wi-Fi to be cut off on your system when you happen to have a test running? So there were several different test coverage things being created for the various scenarios. And I wanted to get a better idea of what the test coverage was like. I don't want to have to figure out from a web page what I need to do. It's going to show me the statistics, but it's not going to show me what's important, what's easy to fix, that kind of thing. So I thought, what if I can get my AI coding assistant model, whether it's Claude or Codex or whatever, to give it access to that coverage data and let it do its thing, which it's really good at, analyzing source code, and give me a report, or let me ask specific questions. Where's the best place for me to start adding tests, that kind of thing. What needs it the most? What's critical? And so I thought, well, a model context protocol server would be the way to go. Would you like me to spend a couple minutes talking about what MCP is?
Yes.
Yeah? Okay. So model context protocol is a protocol with which a coding agent, or a model, actually an LLM, can basically call a function on your local machine to get specific targeted information, or to mutate something, to execute something, whatever. But anyway, it's a way for the model to reach into your system and access a resource that you provide to it. The simplest MCP servers are simply scripts. And Ruby is obviously a handy language for scripts. So the simplest form of MCP, in order to communicate with the coding agent, because it's actually Claude and not it's actually Claude code and not the Claude model that's calling the server. The way that the agent, Claude Code or Codex, communicates with the server in the simplest form is by standard input and standard output. So when you write an MCP server, the simplest way to do it is to just take the requests into standard input. You don't need networking, you don't need HTTP. It's just standard input coming into the machine because it's all running on the same host, right? So you don't really need networking. You have this server thing running, and it's taking the requests in its standard input, and then it's outputting to standard output the answers. And this is done in JSON, and there's a certain kind of dance that's defined as the way that JSON has to be done. As a result, it's very fast. You know, we got standard in, standard out, JSON. It's very fast. Any questions about that? Okay. The coverage tool that's widely used in Ruby is SimpleCov. And I looked to see if there was a SimpleCov MCP around, and I could not find one. So I thought, well, this would be a great project for me to write my first MCP server, which I did. And in line with my philosophy of having command line applications have multiple interfaces, multiple clients, I decided, well, okay, so the coding agent, like Claude Code, I want it to be able to communicate with this software product, but I also want to be able to access it on the command line. And so I added a command line interface to it as well, so that humans can get the same information that AI agents can. On that command line interface, that information can be output in either human readable format or in JSON. SimpleCov creates a JSON file containing all the data that it computes. And so there wasn't even any need to be connected with the SimpleCov gem at all. We're just looking at the JSON file. So there was zero dependency on SimpleCov. But SimpleCov does create a nice web page with coverage information, and this tool is not a substitute for that. The tool requires 3.2, at least 3.2 Ruby version, because that's what the MCP gem requires. High-level objectives, want to be able to query the coverage programmatically, like in a script, integrate with the AI tools, obviously, automate the analysis, and also focus on specific files sets. You know, maybe you want just models, or just controllers or whatever. So key features: no SimpleCov dependency, flexible result set location. So with the scenario that I described before with Wi-Fi Wand, I would rename the coverage directory to coverage Ubuntu or coverage Mac or something like that. So I'd have several coverage directories in my code base. And so using this tool, you can specify which result set you wanted to analyze. And so that could be helpful sometimes. No? Okay. In addition, another thing that I learned when writing command line applications is it can be very nice to enable on the use of an environment variable that provides default arguments to a command line execution. So that's what this is. That can be helpful as well. It detects staleness. So, for example, if you're querying the MCP, it's looking at the result set, but what if you modified a file since that was created? Well, then it's stale. It might not be significant or important, but if it is, you can specify if there's a staleness situation, raise an error, or you may not care, and you can do either of those two. You can add a JSON option to your command line, and then whatever it is that it's outputting will come out in JSON. You can show source code lines, uncovered lines, in the context of the other lines. There's colored output. Here's an example Okay, I'm going to run this. So here we're going to echo this JSON string to the executable, which is simplecov MCP. Now, this is not using command line arguments. This is the way that the coding agent communicates. And so let's copy that. And then I'll go to make this a lot bigger. Oh, wrong clipboard thing. Let's see. Let's try that again. Okay. So it came back, and it came back with a JSON response. So actually, if I then pipe this to input JSON, output awesome print. Let's see if that works. No. Oh, okay. And okay. So this is more readable.
What's RET?
I'm glad you asked that question. I'll pay you later. That's a gem that I wrote. It's it stands for Ruby Executor, and it's a tool that, among other things, does format conversions. You could also format it as YAML or whatever. But in addition to that, it also lets you execute code. So what it does is it provides some functionality to make a Ruby task much more compact, such that it may fit on a command line. So it's like Ruby -E. You can pass code on the command line Ruby -E, and it'll execute it for you. But Rex has some features that can make it much more concise, so that it's more practical to fit it on the command line. And that's a gem, and it's also on GitHub. Okay, so that is how we emulate or simulate the communicating with the tool as we would, as the coding agent would. So given this information that it can get, the coding agent can get, then it can do all kinds of analysis on it, such as these things. These are the tools. Oh, okay, sorry, this is messed up. The second one is the replacement for the first one, but I forgot to delete the first one because I added some new tools. So these are the tools, and I put tool in quotes because really I think it's more useful and comprehensible to think of them as functions rather than tools, because these are the things that that the agent can call to get data back. So, but they're called tools because that's what the MCP protocol calls them. So these are the tools that this code base provides. There's a little purpose here and some example commands, and I'll show you what those look like when run on the command line. This is actually, oh, I'm surprised. I didn't recreate a gem. Okay. Anyway, this is also what you get if you don't specify a parameter as well. You get a list of the files in ascending order of coverage. So you see the worst problems first, and shows you the percentage, covered lines total, and whether or not something is stale. If I were to do this, touch that, and then run it. Hold on a second, my bar is ready. Yeah. Then we see this exclamation point here, right? That's showing you that it's stale. And then if I run the test again and run this again, it'll show that it's not stale because the test generated a new file. Okay. So let's go back to here. If we wanted to get more detail per line hit counts, we can do that. And this shows how many times a given line was executed during the test suite, a few in some cases. And we want to see the raw, this is just an array where the index is the line number and this is the value. Now, what's the difference between 0 and nil? Anybody have an idea? We got a 0 here. No? Okay.
This is in terms of coverage.
Correct.
These all lines again?
Yeah, these would correspond to lines in the source code. So the first nil would be line 0, then line 1, etc. And this line would have 1 hit, and etc. But this line has 0 hits. So what's the difference between 0 and nil?
Well, I'm going to guess that nil doesn't pertain to actual executable code, whereas 0 is actual code that didn't get hit.
100% correct. Good. Okay, that's right. And that's why if you add up the two, the covered and the uncovered, it still won't be the total number of lines measured by WC minus L, for example. Okay, so let's do another one. Summary, more human readable. This has been deprecated. The help just shows you the help. Oh, wait a minute. Oh, I got to change that. This is really the help. Yeah. Oh, that's a bug. I got to fix that about the help command. But here's the help. While we're here, let's look at list, summary, raw, uncovered, detailed version. We can specify the result set, and you can just give it a directory if you want, and it'll append result set.json to it. You can specify a root. So if you're not in your project root, you can specify a root parameter to point it to your project root. You can specify that you want the output in JSON, that you want the order descending instead of ascending, that you want to include the source code. This is only for some of the commands. That this is the number of lines around each uncovered line that you want to be displayed. Whether you want staleness to generate an error. If you want to specify certain file globs, you can do that here, and you can log, that's that. So the uncovered looks like that. If here's an example of, we can always add JSON to it, and it'll come out as JSON. And in fact, when the clog configuration wasn't working, and it wasn't able to call the MCP server, it figured out that it could call the command line. And it just called the command line version of it, which I thought was brilliant. Okay, and then version, not sure exactly what this is going to look like. Okay, yeah. Okay, any questions so far? Comments? Okay. Okay.
You're going to show it working with an agent later, right?
Yes. Yeah. So sorry for, yeah.
Yes,
okay,
no problem. I just reserve my questions. I'll just wait until you've done that part before, and then, because you'll probably cover whatever questions I had in that.
Okay, good. Thank you. I'm back. Okay. Just having a problem with my audio. Okay. So yeah, here's an example. You can pass it to JQ, blah, blah, blah. You can limit the files you want to work on. Here's an example of, well, what if you want, like, for example, a Git hook? What if you're on a project where test coverage is super important and you want to ensure that any commit does not reduce test coverage below a certain level? Well, you know, like how we have Git hooks to run tests. We could also have a Git hook to run test coverage, to analyze test coverage. But you might not want to demand the same degree of coverage for all your files. You may have different priorities for different ones. So to simplify things, let's say that we wanted to, sorry, I'm going to go right down to here. Let's say that we wanted to test some files, the critical files should be 100% covered, and the others should be at least 90%. So here's how we would do it. we require, and we get the file information, all the file information, and then we use partition. If you're not familiar with partition, it's one of my favorite methods in Ruby. It's like select, except instead of producing one array of the matches, it gives you two arrays, one of the matches and one of the non-matches. And so it can be very handy for some very concise processing like this. So we get the critical ones and the other ones by calling partition and giving it a condition predicate. And then for the critical ones, we add that particular file if the coverage is less than 100%. For the others, we add it if it's less than 90%. And then if there are any of them, we output a failure message, output the failures, and then exit with a non-zero error code so that the calling environment can see that an error occurred. Well, since you mentioned that, let's go to, okay, so I'll start Claude. And by the way, I could also start Codex, and I could also start Gemini. I have them all set up. Why? Because sometimes I run out of, credits, and also sometimes they can be helpful for checking each other's work. So that can be handy as well. Anyway, so I'm going to look for MCP servers, and it shows me that yes, it's available. And then I can say, anybody have a coverage question they want to ask? Anyway, I'll say using the simple code MCP server, tell me state of coverage per logical section of code. How's that? Okay, that might take a while. So we could do something else. So, okay, so it's asking me. So this is good because it's showing me that it's using the tool, right? And I'm going to obviously say yes. Oh, it's doing this again. Huh. This is interesting. I'm getting that error again, which, you know what I'm going to do? I'm going to use a different model. Let's use Codex. Yeah, I was talking to Al before. Claude has an error regarding the MCP protocol. It misinterprets or it disallows a format that is the legitimate specified format of certain kinds of data transfers. Okay, so general snapshot, cover snapshot. Okay, how about MCP versus CLI versus library access nodes? So while that's working, let's go back and look at some other stuff. So this is the directory structure. There's a tools directory where all of the tools are stored. And then we have the other one. It's not a large code base. So what do we need to do in our source code to make it an MCP server? How much work is it really? Well, the MCP gem makes it easy. However, you are restricted to running version 3.2 or later because that's what the MCP gem requires. So hopefully that's not an issue. there's a base tool. So MCP provides a tool base class for you to work with. So the application base class is a base tool with subclass of the MCP tool. And I'll show you what that looks like. That bigger for you, right? So we have to define an input schema for the transmission of the messages. And then we can do some other stuff. Oh, and this is how we respond. So we're creating an object of a class that the MCP gem provides, this MCP tool response, and we're passing it a hash. And then the MCP tool does whatever it needs to do for that to be correct. And then we just have our own error handling here. Let's see how the query is going. Okay. Okay, so I'll make that bigger for you. Oh, that's ugly. Okay. So coverage by access mode. In any case, what you can see, even without reading the detail, is that it has provided information per access mode. That is, whether the code is being accessed by an MCP server client or on the command line, or is being included in the Ruby code base. So for me, that's amazing, and I like it. Any questions? Is there anything else you want to see in the actual AI client?
What I remember you saying is that this is like it's a simple coverage anyway. It's a read-only tool, right?
Oh yes, correct. Yeah.
So what I've read of the spec is they have like you need to tell them if it's a destructive operation, if it's read-only, if it's idempotent. Is that stuff that you were dealing with at all, or was there any kind of decision like that for your tools that you made, or the fact that it's all read-only, it's all?
I never encountered that. I don't know. I never encountered that. Maybe, but the AI did generate the MCP code, so maybe there's something it did that I wasn't aware of. And we can look at that. Well, actually, that would be probably in the response. Well, no, it could be in the request as well. Yeah, that's a good question. We can ask AI later. Okay, so this is the tools that subclass base tool, and they're getting for free all the base tool stuff, and then they have to add a description, an input schema, and they have to provide a class method named call. And this is where the actual logic behavior of the tool is contained. And this is how you start the MCP server. And this too is coming from the MCP gem. It's a server class. We started with a name, a version, and the tools array. And then we wrap the server in this standard IO transport object. And that's about it. Any questions? Comments?
How do you see yourself using this?
Well, I've already used it especially because this Wi-Fi launch was very sparsely tested. Poorly is another word for it, but it really was, there weren't many tests for it at all. And I needed guidance as to, okay, what are the most important things? Which ones should I do first? Interestingly, sometimes it added tests that added cover, even though I said, give me meaningful tests to improve the coverage. But there were sometimes tests that were not very meaningful, and it was really important to review the tests.
So you were sort of prioritizing your plan of attack on the code base based on the agent going and looking through the test coverage report. Is that
exactly?
Okay.
Exactly. Yeah.
What if you were to just feed the test coverage report into, like, as part of your prompt? Did you try that at all? Like, instead of doing an MCP survey?
That, I mean, that's certainly doable, but then it has to understand what that JSON data is. And having these functions that requires targeted parameters, where you're actually telling it, I want the uncovered, information for this file or whatever, saves the model a lot of work.
Yeah, I guess it allows you to be more precise in what you're focusing on and what you're asking the agent to focus on.
Yeah.
Fair enough.
I mean, yeah, of course it can, it'd be interesting to see, how much effort it had to expend and if we were able at all to just take that file. I mean, I guess certainly what it can certainly do, and I've seen it do, is find the source code and look through it and figure out what it does just by looking at the source code. It's great for stuff like that, but you wouldn't want to make it do that for every single request, So and this saves money too, right? Because you're not using tokens, AI tokens for this for the MCP operation. There may be a little bit, function call overhead and tokens, but for the logic itself, it's the model's not the one doing it, so it saves you money.
Nice. Looks good. Cool.
Thank you for the questions.
Any other questions?
If anybody wants to connect with me later, my email address is keithrBennett@gmail.com, and my LinkedIn is also Keith R. Bennett, 2 N's, 2 T's. Thank you for the opportunity to speak with you.